Alright, graded math 3. This is the answers video for assignment 4.03, 4.04. I'm getting it out a little late, but you still have plenty of time to do it. Try to get this done by Friday, November the 13th. So let's go ahead and get started on this. So what we're dealing with is logarithms and exponents here. Alright, so with this problem here, what you can do is anytime you have an exponent that's wrapped up inside, or excuse me, a variable like x that's inside of an exponent, the way to get it out is to use a log. So we're going to go ahead and take the log of 4 to the 2x and log of 64. And that just follows the basic principle of math, that anything you do to one side of an equation, you can do to the other side. All right, so we have some rules that we can follow here. And the one that we use quite a bit is on this sheet. It's on the front of your assignment sheet, is rule number 12. And it says if you have log of a raised to the x power, you can take that exponent and bring it out in front of the log, like it's shown right there. So we take the x and we bring it out in front of the log. Okay, so we're going to do that with 2x here. It doesn't just have to be an x, it could be anything that's in the exponent. Okay, so the log of any real number you can go ahead and do on a calculator. And so we'll do that here. So log of 4. So I press the log button. It's a little hard to see. I'm going to try to angle it so you can see it. There's log. I put in a 4 parenthesis and I get 0.602. 3 places after the decimal is enough. So we rewrite the 2x. Do the same thing with log of 64. And you get 1.8. We'll round the 06 up to a 1, so 1.81. Okay, now we solve for x. It just becomes an algebra problem. No more logs, no more exponents. So divide both sides by this. That cancels, you divide that, and I can tell you that that's going to be, well, I'll go ahead and do it on the calculator. Becomes exactly 3. So that equals 3. So now what we have is this, 2x equals this, which is 3. Divide both sides by 2. I'm getting a little crowded down here, but 3 over 2 equals 1.5 or 1.5. You can write it either way. And that equals x. Okay, so I'm just showing you the basic math way to do it. I showed you in some of the later problems how to use a common base, so we can go ahead and do that as well here. So I'll do that over here. So what that means is you've got to have a common base. 464. So 4, come up here and write it, is equal to 4 raised to the first power. 64 is equal to 4 raised to the third power. So what you can do is take this 4 and do this, put it in a parenthesis, 4 raised to the first power equals 4, and then to the 2x. With this one, you can do 4 raised to the third power, put that in parentheses, that equals 64. Alright, so now the principle is 4 to the first power, you raise it to the first power, and then you raise it to the 2x power. So there's a rule over here that deals with that. It's this one, number 4. A raised to a power, and then you take what you get from that and raise it to another power, is equal to a raised to those two powers multiplied together. That's a times sign in between the x and the y there. So we can go ahead and do that. So that's 4 raised to the 1 times 2x is 2x. Which equals 4 raised to the third power. So if this equals this, if 4 raised to the 2x equals 4 raised to the third, then it stands to reason that 2x equals 3. It has to equal 3 because these two things equal each other. if you're not sure of that, you can take the log of both sides. Okay, and we follow the same rule that we did in the first way we did it, which is take the x and bring it out into the front right there. So the x in this case is 2x. In this case, it's 3. And what you notice, you have log 4 on both sides, so you can divide both sides by log 4, and the log 4 will disappear. Cancels there, cancels there. So now we have 2x equals 3. So if it wasn't obvious to you looking at it like this, now it's obvious. 2x equals 3. So we can come over here and finish the problem. Divide both sides by 2. Cancel, and you get x equals 3/2, or 1.5, or 1.5. Any way that you want to write that. Okay, so two different ways to do the same problem. All right, next up, let's go ahead and do number 2. Now, I did this one in class this way. I wanted to show you a couple problems just doing it kind of the long form way where you actually take the logs. But it really does make more sense to take the common base. So we're going to go ahead and do number 2 that way. So 4. So you got to ask yourself, 4 raised to what power gives you 8? And the answer is it doesn't. There's no power you can raise 4 to. If you raise 4 to the first power is 4, 4 to the second power is 16. So you skipped over 8. So there's no integer value that you can raise 4 to get 8. But what you can find is some number smaller than both of these that you can raise to a power to get each of these. And I think you can see what that is. 4 is going to be 2 to the second power. That equals 4. And now outside of that, you've got this exponent here. And 8, I think you can see that raised to the 8 is 4. 8 is 2 raised to the third power. That equals 8. Okay, if you're not sure of that, you can just play with the number. 2 times 2 times 2, do that. 2 times 2 is 4. 2 times 2 times 2 is 8. You can just play with some numbers. Most of these, it's kind of obvious what the common base is going to be. Okay, so we can use the same principle, number 4. That same rule that a raised to the x, and then you take that and raise it to another power that equals a raised to the x times y. So we're going to come here, and we're going to take 2 times 1, so it's 2 to the 2 times 1 is 2, and 2 times negative 3x is negative 6x, and that equals 2 to the third power. Okay, so go ahead. You know that now. Okay, so now we have these raised to a common base. So if 2 raised to the 2 minus 6x equals 2 raised to the 3, then that means that 3 and 2 minus 6x have to be equal to each other. We showed that with problem number 1. Now we'll just go ahead and make that assumption. So you have 2 minus 6x equals 3. Okay, and you're going to subtract 2 from both sides. That goes away. You end up with negative 6x equals 1. And if we divide both sides by negative 6, then you end up with x equals negative 1/6. Students have asked me, when you have a negative fraction like that, does it matter whether you put the negative sign on the bottom or on the top or kind of in the middle right there? And the answer is no. It's a negative number. That's all that matters. Usually you put it kind of in the middle right there, and if it's a fraction. Okay, so we got negative. So we got negative 1/6. So one thing you can do is if you go back to the original problem here, up here, and you put a negative 1/6 in for x, you get negative 3 times negative 1/6 is going to give you a positive 1/2. Okay, just kind of do that off to the side if you want to. So 1 plus positive 1/2 is 1.5. That's 3/2. Okay, so let me show you how you would check that. It's 3/2. So you would have 4 to the 3/2, and this is a principle that we are going to get to, equals 8. So what does that mean when you raise it to a fraction like that? It means what you do is you raise 4 to this power and then take this root of it. So it's 4 to the 3rd power, and then you take the square root. Whatever's on the bottom is the square root. You don't have to write the 2 out there, but that's a square root. So 4 to the 3rd power equals 64. And the square root of 64 equals 8. So 4 to the 3/2 power equals 8. We'll practice some of those problems on Friday. Okay? Anyway, the final answer, this was just checking the work by plugging this number back in. But this is the final answer right there. Okay, the rest of them we're going to do using the common base as well. All right, so the only trick here is what's the common base? Well, 2 is definitely going to be the common base here because it's the only common base you could have for 2 itself. But how do you deal with this? Well, you take this number 32 and you say 32 equals 2 to the what power? What would that be? And if you don't know, you just do a trial and error. 2 times 2 is 4. 2 times 2 times 2 is 8. 2 times 2 times 2 times 2 is 16. And 2 times 2 times 2 times 2 times 2, that's 5 of them, is 32. So it's 2 to the 5th. But this is not 32, it's 1 over 32. And the way you always get a reciprocal or a fraction like that on the bottom is you make it 2 to the minus 5th. Minus 5th flips the 32. You can write that as 32 over 1. So that's 2 to the 5th. And 2 to the minus 5th is 1 over 32. It doesn't make it a negative number. It just take the reciprocal. All right? So that's going to be the common base for 1 over 32. So we'll go ahead and write that over here. Again, you have a common base. If 2 raised to this power equals 2 raised to that power, then these two exponents have to be equal to each other. So x equals -9. So let's try that out. If we put -9 in for x, you get -9 plus 4 is -5. So that makes this 2 to the -5. And that's what we said 132 equals. It equals 2 to the -5. So that checks out. Okay, common base for this one. In class, I think I did 5, but you didn't have to do 5. Yes, you did. I'm sorry, you did. You have to do 5. 25 does go into 625. If you square 25, you get 625. So 25 could be a common base for 625, but it can't be a common base for 125. 25 to the first power is 25. 25 to the second power is 625, so you skipped over 125. So what you're going to have to do, the obvious one, this one kind of jumps out at you, it's going to be 5. All right? So what you got to figure out is this is 5 to the what power, this is 5 to the what power, and this is 5 to the what power. And again, you just do it by kind of playing around with 5s and raising them to different powers. So 5 to the first, let's just write down what they are. 5 to the first equals 5. 5 to the second, you just do these on your calculator, is 25. 5 to the third. And 5 to the fourth. Okay, so that's all the combinations that you're going to need. So this is going to be 5 to the fourth. This is going to be 5 to the second. And we said that 125 is 5 to the third, but it's 1 over 125, so we told you what to do with that up here in this problem. It's going to be 5 to the -3rd, okay? So let's go ahead and write that out. So in parentheses, you put the part that just exactly equals 625. That's this part right here. And then you have this exponent on the outside, so you go ahead and write it on the outside. Okay, that's going to be times 5 squared. For 25, you put that into parentheses, and that's -x minus 3. And then this is 5 to the negative third. 125 is 5 to the third, but it's the reciprocal of that. It's 1 over 125, so it's 5 to the negative third. Okay? So now what do you do with this? Well, you use this principle. You have first of all, we have to expand this. We have to multiply these two. So we're going back to rule number 4, a raised to the x, then raised to the y is a to the x times y. So we're going to go ahead and make this 5 to the negative 4x times 5, and it's 2 times negative x, so that's negative 2x, and 2 times, let me be careful, that is a 5, it's not a negative sign there. Okay, it's 2 times negative 3 is negative 6. And then over on this side we still have 5 to the minus 3. Okay, so now what do we do with these? Well, you use this principle right here. That a base raised to a power times the same base raised to another power, you add the exponents together. So that means we're going to add this exponent and this exponent together, because that's what we have. A to the x times a to the y, and again, y can be more than just a single variable. It can be this whole thing. And so that means you add these two. So we're going to come down here and do that. Okay? We just strung them all together and added them all together. And that equals 5 to the negative 3. Okay, and we've been here before. You have a base raised to a power equals the same base raised to a different power. That means that this has to equal this. They have to equal each other. Again, if you want to do it the proper way, you take the log of both sides. You bring these out in front of the log. The log of 5 will cancel out on both sides, and you'll end up right where we're about to end up, which is right here. And that should have been an x right there. Okay, so now you just have a simple algebra equation. So negative 4x minus 2x is negative 6x. And you're going to add 6 to both sides. That goes away, and you end up with positive 3 over here. I'll just bring the answer up here. So it's negative 6x plus 3. Divide both sides by negative 6. Which equals 3, rather, I'm sorry. Yeah, equals 3, I'm sorry. Equals 3, negative 3 plus 6 is 3. Okay, and divide this by negative 6. This cancels out, the negative 6 is there, and you got x equals 3 over 6 is 1/2 with the negative sign, so it's negative 1/2, okay? And if you plug this into the x's there, I'm not going to do it because it's kind of messy, you would confirm that that would equal 1 over 125. Okay, so that's how you do these with common bases. All right, let's keep moving on. Okay, same thing. So I'm going to do number 5, and this one is for you to do. I'm not going to do this one. That's for you to do by yourself. It's done exactly the same way with common base. So let's go ahead and do this one, though. So 3 to the first equals 3. Okay, so there's all your powers of 3 as far as you need them, up to 81. Okay, so come over here. All right, so now you go ahead and use the principle we talked about of this one, number 4. A raised to the x, and then taking that and raising it to the y is multiplying the exponents. So this one becomes, all right. Now we need to combine or consolidate, combine these two together. And again, you do that using this principle right here, number 3. So it's going to simply be 3 to the just combine that, add those two together. Add all that together. All right, and we've seen that if 3 raised to this power equals 3 raised to that power, then these two exponents have to equal each other. I'm going to come up here and write that up here. Okay, so there you go. It's just a simple algebra problem. We'll combine 5x minus 4x gives you x plus 4 equals 2x minus 6. Subtract x from both sides. Let me get rid of this. Wrote that in the wrong place. I'll just write it down here. You do number 6. Okay. Subtract x from both sides. These two disappear, poof, and you end up with 4. 2x minus x is x minus 6. You add 6 to both sides, and you get 10 on this side, and this goes poof, and that equals x. So x equals 10. Okay? And again, if you plug the 10 in for that x, and for that x, and for that x, you would end up with the correct answer. They would be equal to each other. That's what that's saying. All right. Hopefully that's not too bad. All right, so you're going to do number 6 all by yourself. And, let me pause for a second and say you should really be attempting all of these by yourself. I'm giving you the answers not just so you can copy, but so you actually know whether you're doing it right. I always found when I was taking math, if I didn't know an answer, I wasn't that motivated to do it because I get an answer, okay, fine, I don't know whether I did it right or not. I always wanted to know whether I did the problem right. So I'm giving you the answers and the solutions both so you'll know whether you did the problem right if you do try it on your own, which you should, and to show you the solution if you absolutely don't know how to do it. And remember, when you watch the solution, if you're doing this the way you should be doing it, don't just watch the whole solution. Watch the first part, the first step, and then stop it and see if you can do the rest of the problem from there. If you can't, then watch the second step and see if you can do the problem from there, and so on. Okay, so that's kind of the way you should do this if you're doing this seriously. Don't just copy. That won't teach you anything. Okay, here we go. So now we're on to what's actually lesson 4.04. I've combined those two lessons. So it says use the properties of logarithms to expand each logarithmic expression as much as possible. Where possible, evaluate the logarithmic expressions without using a calculator. Well, you have a single equation here. It's not an equation even, it's an expression. So since you don't have an equation, you really can't come up with a specific number value for x and y. The other issue is, even if you had this expression equals 10, for example, you only have one equation and you have two unknowns. So you have to have as many equations as unknowns. So the point is that you can't come up with specific number values for x and y here. All right, but what we're going to do is we're going to just, play around with the principles of logarithms to do this problem. So what you have is you have a logarithm, and inside that logarithm you're multiplying two numbers together, x and y to the third. So the principle that applies to that is number 10 here. It says it's going in the other direction, but you can start over on this side. If you have a logarithm where you're multiplying two numbers together, then you can break them out like that and put a plus sign between them. So log of a times b is log of a plus log of b. So we're going to go ahead and do that. Okay, so there you go. That's how it does it. The only other thing you could do if you want to consider it further simplified, and whether this is simplified or not, just go ahead and do it. You want to put the 3 out in front of the log here. So your final answer would really be this. Okay, and that is that's your final answer right there. Okay, not too bad. Move on. All right, so here we have log base 5 of 125 over y. So there's a similar principle for division, and it's number 11. That if you have a log of a number over another number, then it's simply log of the top number, a, minus log of the bottom number, b. So we'll go ahead and use that. Okay, and there it is. That's the way that would look. Now, this one you can actually evaluate for a specific number. Remember what a log is. It says you have a base and something called an argument. The argument, don't worry about that name. It's just that. It says what power do you have to raise 5 by to get 125? Well, we've already done that one in an earlier problem. It would be 3. So 5 to the third power would give you 125. And so that means this number would be 3. But what if you didn't know that? What if it wasn't something obvious like that? What you can use is, for this, is the change of base. And change of base is a really neat formula. So let's look at that one. Change of base says if you have log of some base x, it could be some oddball base like 5, because your calculator won't do a base 5 problem. Of an argument y, it's the same as log of y to any base you want to choose for b right there. It could be anything you want. And of course, the one you're going to choose is 10. So you always want b equals base 10, because that's the one your calculator does. And then it's the log of this base here, x, and that's also to the base 10. All right, so let's see how that works. So we come over here. I'm just going to do this part, evaluate this. So log, that's going to equal this. Okay, and you don't have to put 10 when it's base 10, because that implies, log always implies that. Okay, and it's going to be that over this. Okay, so this, you just get on your calculator. Get on your calculator. That's what this log is. It's a base 10 log. And you put 125, close the parenthesis, and I get, I know it's hard to see, 2.09. You round that up, it's 2.10. 2.10. I'm not picky about how many decimal places. You should go at least 2. And then that's over log 10, base 10 of 5. So we're going to do the same thing here. Try to make it so you can see it. So log, let me get it in focus here. Log of base 10 of 5. And that's going to equal 0.699, I'm going to call it. Okay, and if you divide 2.1 by 0.699, and the calculator says I get 3.00 blah 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 blah, but it's 3. It really is 3. It's just because I rounded. It's just because I rounded these, so it's 3. And that's what we said. We said 5 raised to what power gives you 125? It's 5 to the third power. So you can actually write this number. You could write it, leave it like this if you wanted to. Or you could just go ahead and simplify that and write it like this. You may say, well, how do I know which I should do? If you did it reasonably, if you left that, I would say that's fine. Unless they specifically said, evaluate that, simplify that part as well. You'd be okay. So this is really your final answer, but that's acceptable as well. All right, let's go. Okay, so now we get into some roots. So I'm going to introduce it's really not a new property, but I didn't state it explicitly. We said this, that an x to the 1 over n is equal to that root of x. So if this was x to the 1/3, this would be the cubed root or third root of x, okay? So let me expand that a little. If I said x to the m over n. So in other words, the exponent is a fraction. That's equal to x raised to the top number there, the m, and then you take the n root. The bottom number is the root. Okay. So I showed you an example of that earlier. Let's just go ahead and take an example. What about 4? There was an example in one of the earlier problems, in other words. 4 to the 3/2. Okay, we had that in the earlier problem. What that is equal to is 4 to the third power, and then you take the square root of it. You don't have to write the 2 there, but it's a square root. So 4 to the third is 64. And the square root of 64 is 8. So So you raise it to the power of the top number in the fraction, and you take the root of the bottom number in the fraction. Okay? So we'll run into that principle a couple of times in the next few problems, all right? It's really an extension of this rule over here, right here, okay? So here we have log base 2 root 5 of all of this. So that's a big mess. So what do you do? What I would do is always get rid of square root signs to the extent that you can. So what I would do is write this as, I would use this principle right here, that the nth root of something is equal to that thing to the 1 over n power. So I would write it like this. I'll come over here. I'll start doing my problems over here. I'm going to put this whole big mess in parentheses. And I'm going to raise that. The whole thing is raised to the fifth root of it. So I'm going to raise this to the 1/5 power. Okay, so this is equal to that. You just changed it from a square root into an exponent. All right, so what's the next thing you can do? And let me make it, that's a bad looking 4, so let me be clear. That's a 4 raised to the 4th power right there. Okay. All right, so what do you do now? Well, we know from this principle right here, number 12, that we go to a lot. If any exponent, we can pull out in front of the log. So I'm going to take this 1/5 and I'm going to bring it over here. 1/5 log base 2 of all of this. Okay, so the 1/5 is no longer up here. It's now out in front there. Okay, now what? Well, we have something times something divided by something. All right, so let's see how that works. Let's take something times something. Log of something times something. Here it is. It's this one right here, number 10. Log of something times something equals log of the first something plus the log of the second something. So we're going to write this, and I'm actually going to do this all at one time. And then this rule, number 11, says the log of A divided by B is equal to the log of A minus the log of B. So let's see how that's going to work. That means we're going to have, and we always have to keep, we're going to keep the 1/5 outside of the parentheses, and we're going to do this whole thing inside of a parentheses. Okay, so it's 1/5 times log base 2 of x plus log base 2 of y to the 4th. Okay, again, that's rule number 10. We're just splitting them out and putting a plus sign between them. Okay, so we've done that. Now that's divided by 16. So what do you do when you have something divided by something? You use this. Log of A over B equals log of A minus log of B. So we're going to count this entire thing as the log of A. The 16 is the log of B. So now we're just simply going to subtract. And we're going to keep that all in parentheses. So that's a little tricky. Be sure you're comfortable with that. Log of x times y to the 4th is log 2 of x, log 2 of y to the 4th. And then you divide by something. That means you're going to subtract this. So it's minus log 2 of 16. So just look at this, look at that, until you're comfortable that that's all okay, because it is all okay. All right. Now, one thing we can do to simplify this is we can take this exponent of y here and bring it out in front of this log only. Not in front of the whole thing, but in front of this log right there, okay? So I'm going to write 1/5. And now, log base 2 of 16 is asking what do you have to raise 2 by to get 16? You could use the change of base formula. That would be log base 10 of 16 divided by log base 10 of 2 and figure it out. But a lot of you may be at the point where you can just look at this. 2 raised to what power gives me 16? 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16. That means this entire term equals 4. Log base 2, 16, argument 16, it returns 4. So I'm going to go ahead and put a 4 here. That's this. Again, go back to the last problem and see how we used to change a base to fit using base 10 to figure out how to do that on our calculator, and you would end up with a 4. Let's put it this way. If you left it like that, that's perfectly fine. Unless I were to say, yeah, you gotta simplify that. Okay, there's only one more thing we could possibly do. We could distribute this 1/5 through to everything. So let's go ahead and do that. This to me is a perfectly good answer. Or it could have been 1/5 just multiplied it by that, plus now you're going to multiply it by this 4 here, so it's going to become 4/5. 1/5 times 4, the 5 just goes down on the bottom, 4/5. Minus the 4. Okay? And that is the answer to that, all right? Excuse me, minus 4/5. I goofed. The 1/5 times the 4 is 4/5. Okay. I bet you some of you saw that before I did. Okay, that's it. Either one of these answers I would consider acceptable. They're fine. Okay. All right, let's move on. It says, use properties of logarithm, blah, 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 write the expression as a single logarithm. So that means you want to write it so you only have one log. Okay, you only have the word log one time. That's what it's saying. All right, so here we have a log base 3 of u plus 6 log base 3 of v. Those are two different letters there in case it's hard to tell. Okay, those are two different letters. So what you have is a log of a certain base plus a log of a certain base. So what principle would that be? That would be this one, number 10 again. Log of a, the base is, you assume, is the same here. Log of a plus log of b equals log of a times b. So first thing we're going to do is this. We're going to use this principle, number 12 again, except we're going to go backwards. We're going to take the 6 that's out in front there and we're going to put it up as an exponent, like up there, right? Okay? So let's do that first. Okay, so we just took the 6 and put it up there, took this 6 and put it up there. Okay, now we can go ahead and use the principle 10 that we were just mentioning too. Log of a times b is log of a plus log of b. All right, so what does that give us? It gives us log base 3 of u to the 6th times, I'm going to use a dot for times here, put in parentheses, v to the 6th. Okay, and you can simplify that one more step by writing log base 3 parentheses u v, and outside the parentheses put the 6. All right, because what this would mean is you take this 6 exponent and you distribute it here and you distribute it there. So u to the 6th, v to the 6th, which you have there. So this is actually the final simplified form for this, okay? I would accept that as an answer as well. All right, because you did what it told you to do. You made it in a single log. You used just the word log one time. That's what it was asking you to do. So that's perfectly acceptable. Either of those is good. All right, again, if you kind of get familiar with these, this won't be so bad. All right, let's do the same thing with this one. So here we have, it's kind of like two problems back. You have a log, all the log bases are the same, otherwise you can't do the problem. They all have to be the same base. So here you have a log plus a log, and here you have minus a log. So these two are going to be multiplications. This one's going to be a division because it's a subtraction. So again, we go back to 10. When you have multiplications, they become log A plus log B. When you have a division, it's log A minus log B. So it's going to look like this. First thing is, let's take these coefficients out in front of log and make them exponents here. So we're going to change this. Okay, so I just went ahead and put those things like that. And now we're going to go back and use these principles 11 and 12. So we have log 4, log 4, log 4 in all cases. So we're just going to write log 4, log base 4 one time, and then I'm going to make a big parenthesis here, and I'm going to have x to the third times x times y to the fifth, because those are being added in log form. And then I have minus z to the sixth, so that means that's going to be a division. Again, it's principles 11, 10, and 11, and you're working from right to left here. It's times becomes a plus. Excuse me, you're not doing that. I'm sorry, that's wrong. You're doing plus plus. You're doing plus this gives you a times, and when it's division, when it's a minus, excuse me, it gives you a division. So these two were pluses, so that gives us times these, and this one is a minus, that gives us a divided by this. And there you go, and there's nothing else you can factor out of that, so that's your final answer. You'll notice this is only a two-step problem. It looks complicated, but if you understand the principles and you practice these principles, it's not that bad. These are fairly quick problems. Okay, let's keep going. Okay, again, we have a log to base 10 because there's no base there. It means it's base 10. And you have something out in front of the log. That means you can bring it up as an exponent. So let's go ahead and do that. Okay, just brought that and put it up there. Same thing over here. Okay, so now you have that. So now what you're going to do is you're going to multiply the x to the 1/2 times this, and that's simply, and then you're going to put them inside of a single log. Just go ahead and use a parenthesis there. Okay, and I'll go ahead and put that out there, so I actually have two sets of parentheses there. Okay. All right, and the alternate way to write this then is you could write, this is the square root of x. X to the 1/2 is the square root of x, so you can write it like that if you want. This is really just a preference, times x minus 1 to the 4th. So either of these are acceptable ways to present the final answer. Okay? Again, not very many steps to solving this problem. Okay, number 7, you got a log plus a log of this minus a log minus a log. So these are going to be multiplications, and then it's going to be divided by this in the denominator. That's going to go in the denominator, and that's going to go in the denominator. So this is the other u problem. Okay, so it was number 7, I think it was, or 8. Anyway, I wrote u next to it. So you're going to do this problem by yourself. I'm not going to show you this one. All right, and I'm going to leave this one for you to do. I'm going to set it up for you, though. Okay, you just have to do the calculation. So again, you have some kooky base like 16 that your calculator won't do. So it's a change of base. So use the change of base, number 16. So this is log, what is it, 16 to 57? So this is log, the x is 16, the y is 57. So the 57 is going to go up here, the 16 is going to go on the bottom, and the b is always going to equal 10. So I'll set it up for you and you solve this one. Again, I don't need to write the base 10, you just assume it if it was just log, but I'm going to do it anyway, of 57. So you can compute that on your calculator. You can compute that on your calculator. When you get those, then you just divide this one by this one, and that will give you your answer. So you're going to do this one as well. Okay? So that's the ones. And remember, if you come to tutoring, I'll work any problem with you, including the ones that I left for you to do. All right? But I want you to at least attempt them on your own. Okay? All right. That takes care of it. That's a 100-point assignment. That's 2 assignments put together. It should be in by Friday. I'm recording this a little bit late, Wednesday morning. but it's still, you got plenty of time. You saw how quick these problems were, and I've done all but 3 of them for you. So go ahead and finish those up, and I will see period 3 on Thursday, and I will see period 1 on Friday, but this assignment for everybody is due on Friday. Okay? So I'll see you in class.